Now, with activity 5D, this is where I'm really going to deviate from what Sibylla Beckman, the author of the book, is leading us to. So you can see by the way that this problem is set up that she's leading us to the use of key terms, that the word of means times, and that's what she's trying to do. She's trying to make us say something in the format of something is shaded. And because then that's easier to rewrite as a multiplication. The problem is that's not how problems show up in real world. And using the key words, as she is suggesting, in my opinion, is not a reliable strategy. Keywords or key terms. So we're going to avoid those keywords and key terms. And instead, we're going to go back to our definition of fraction and see how we can make sense of this as based on our definition of fraction. So let's look at this. How many of these do we need to fill the whole? And the whole is that whole rectangle. Well, if we look at the way that it's cut, it's 1, 2, 3, 4, right? So it's 4 to fill that section. And then there are 3 of that section. So times 3. So it's going to be 1 of 1/12. So 3 times 4. Does that make sense? That it's 1 of 3 times 4. Because initially we found that we need 4 of them to fill this portion, and there are 3 of those. So we need 12 in total. So 1/12. Same thing here for B, for example. We have 3 pieces. All right, well, that's good to know. But how big is each piece? Well, each piece, we need 1, 2, 3, 4, 5 of them to fill that section. But we have 4 of those sections. So it's 3/20. Now, let's take a look at this. We have, we could actually make a different kind of sense from this one. If we are looking at this as a single piece, we have 1, 2, 3, 4, and then we could fit one here, 5, and the other one here, 6, right? So we can right away say it's a 6th. The way that they were suggesting is, let me grab a different, because of these tick marks, I think that what they're hoping that we do is look at this and say that there are 2 of these pieces, and we need 2 pieces, 1, 2, 4 of those, right? So 4 times 2, and then 2 more. So not 4 times 2, but there are actually 6 times 2 in here. 6 times 2. So that would be 2/12. And we know that that's equivalent to 1/6 if we make the pieces bigger, which is our first solution. Okay. So do you see the idea? The idea is that I'm not trying to immediately jump to the fact that this is a multiplication of fractions, and look at how you do multiplication of fractions. What we're actually looking at right now is going back to the definition of our unit fraction, still continuing to make sense of these drawings the way a child would. Once they've made sense of it, they might come back to you and say, but wait, that's the same as 1/3 times 1/4. They might do that, right? They might. But this particular situation is not necessarily going to get them there. There are other situations that will. And what we need to do is explore those separately and then connect them to each other. That they're just different sides of the same coin, different representations of the same idea. So what I would like to do is at this point deviate from this and take you to the area model for multiplication of fractions in your fractions packet.